Sorry about that. As soon as I paused that last video, because before YouTube only let me put like 15-minute videos, but last week I changed the settings so I could put more than 20-minute videos or whatever the limit was. So I apologize. There's no need to create a second video. But all right, so let's keep going through the examples here, and then I'm gonna pause and have you try the checkpoint, and then I'll show you the checkpoint on the video. So that'll be the format, because I'm not gonna have, this is the first time you've done these, so I'm not gonna have you do the checkpoints and like send them in to me. I want you to be able to check yourself right there on the spot. So let's do an example, and then you should pause the video and try checkpoint 1 at the bottom. So first, this is exciting, guys. We're graphing our first quadratic. So we're not solving, we're not factoring, we're just graphing it, okay? So just to recap, if you think about it, we've been in linear world before, we've been in exponential form before, and now we're in quadratic land of graphing. So pretty cool stuff. So let's go through the first example. So you'll see here, graph 1/2 x squared and compare it to y equals x squared, okay? So just again, this is our parent function. So I'm trying to think if I got a different color that I can use. I'll use this purple. So our y equals x squared. This is the parent function. So if you notice here, a equals 1. There's an assumed 1 there. So we're going to see what happens when we change a to 1/2. All right. So let's just graph our parent function here, just so we have something to compare it to. So again, like I said, it starts at 0, 0. 1 squared is 1. 2 squared is 4. And 3 squared, now I can show it to you, is 8, 9. And again, now that I know that this is my line of symmetry, I don't really have to think too much. I just go here, over. This goes over 2, over 2. Just follow, keep it symmetric. 1, 2, 3. 1, 2, 3. And then again, we draw that smooth curve, but not exponentially. It's a parabola. Okay, so again, this is y equals x squared. All right, so let's see what happens when we do 1/2 x squared. Maybe you can, in your head, think about maybe it's gonna do something to that parabola. So let's find out here. So the first thing I'm gonna do is make a function table. Once I have my table of values, I just plug it in. So just plug in x equals 0. So 0 squared times 1/2 is still 0. Okay. For the next one here, again, I just need to do 2 and 4, because then I know -2 and -4 is symmetric. So I will go here and I'll do 1/2 times 2 squared. So that's 4, and 4 times 1/2 is just 2. So I know I'm going to put a 2 here and a 2 there. The next one I'm going to do 1/2 times 4 squared. 4 squared is 16, and 16 times 1/2 is 8. So put an 8 here. So now I'll graph it. I'll try to use a red marker, I guess, or a red pen here, so you can see the difference. So here, I'm going to go 0, 0, still my vertex, so the vertex hasn't changed. I'm 2, 2 now, so over here. And if I put a dot there, I can go on the other side, put a dot here. All right, -2, 2. And then my next one is 4, 8. So 4, and then all the way up to 8. And then 1, 2, 3, 4. 2, 3, 4. Okay, draw my smooth curve. This. Like that. So there's my 2 parabolas. So this one again is 1/2 x squared. So yeah, we did this stuff. Step 2 was to plot the points. Step 3 is draw the smooth curve. And now we can make some comparisons. So it says here, y equals 1/2 x squared and y equals x squared both have graphs that have the same vertex. at 0, 0. And the line of symmetry is still, we'll just put y-axis. However, the graph, you can see, I don't know what adjective you would use, but I would say that 1/2 x squared is wider. It almost like takes the parabola and like stretches it out and makes it a wider parabola. So I'll put here the word wider. Okay, then y equals x squared. Yeah, so this is because 1/2 x squared is a vertical shrink, they say. If that makes sense. By a factor of 1/2. All right, so interesting checkpoint here. So with this one, I'll get you started with this checkpoint. You're going to graph this one here. So it's -5 is now a. So first time you have an a that's negative, so you'll put x, y. I'll start you with, because there's not a lot of room here, use 0 and -1 and 1 and 2 and -2 and compare it to y equals x squared. So there's not much of y equals x squared that you can see here. 1, 1 is like here. 2, 4 is like there. And then that's pretty much it. So you get not much of that you can see here. Yeah, so that's your y equals x squared up there. So pause the video from home, see if you can fill in these values and graph them here, and then we'll talk about the comparison. All right, so hopefully you got something that looks like this, if you did that checkpoint correctly. So you can see here it's negative. So yeah, so 1 squared is 1 times -5 is -5. 2 squared jumps it up really big here. 2 squared is 4 times -5 is -20. So when you do that here, you go, 0, 0, 1, -5, and then of course there's -1, -5, and then you go 2 all the way down to -20 and here. So what are some of the comparisons you might have said? I would say that when a is negative, in this case -5, it gives you a down parabola, right? Not only does it give you a down parabola with the negative part, the 5 compared to the actual number 5 compared to the 1 there. Hopefully you noticed that it didn't make it wider, but it actually made it narrower or skinnier. So I'll say 5 made it skinnier or narrow. Okay. On another video, I'll use Desmos and show you like exactly how this works. But for now, let's turn the page, and we're trying example 2 and example 3. All right. So let's kind of like preview these examples here. You see here, now we're going to add a c value of -2. Okay, for that example, and then over here, we're going to not only put a c value, but we're going to make that -3 for my a. I already know that that -3 is going to make my parabola go down, and it's going to make it get narrow. But we're going to find out what's going to happen with this c value now, because that's some interesting stuff. So let me just get my other one here set up. Okay, so okay. Comparing it to y equals x squared, I'll just throw that in there really quick. Go a little quicker. 1, 1. This is just my x squared. 2 times 2 is 4. Sorry, that's 4. Okay, and that's 4 here. Smooth curve. That's my y equals x squared. Okay, so now let's make a table of values for this. Y equals x squared minus 2. So see what happens now. So when I put in x equals 0, 0 squared is 0 minus 2 is -2. Interesting. Our vertex is no longer at 0, 0. Now if I put in 1 squared is 1, minus 2 is negative 1. It's a line of symmetry here, so I can put a negative 1 here. 2 squared is 4, 4 minus 2 is 2, and so I can put, again, a 2 here without even thinking. So now, when I graph this one, you'll notice here 0, negative 2 goes here, okay? And then 1, negative 1 is here, and here. My line of symmetry hasn't changed, it's still there. And then we have 2, 2 will be here, and negative 2 to here. So this is my new graph. So I don't know about you, if you're, no offense, no pun intended, I just said you and I thought of parabola. But here are some comparisons I can say. So I definitely noticed that the vertex is the same. So they both open, let's put in some of the words here. They both open up, have the same line of symmetry, which is the y-axis still. However, the vertex of y equals x squared minus 2 is different. So the vertex is different. So is not 0, 0 anymore, but it's 0 and then negative 2 here. Okay. It is different than the vertex of y equals x squared, which is 0, 0. And then so now y equals x squared minus 2 is a basically a shift, I would say. A shift of down of 2 units down the y axis, I would say. So that was interesting. So get an example again. So again, it is same line of symmetry. It just shifts this whole parabola down 2 when your c value is negative 2. So just for the heck of it, if I wanted to, if my c value was plus 2, it would have shifted the whole parabola 1, 2 up to here and started there. All right, example 3. Let's graph y equals negative 3x squared plus 3. All right, we can do this. So let's quickly throw in y equals x squared to compare our parent function 0, 0. I think this is going by ones. Let's see. No, it's going negative 3, 2, 4, 6, 8, 10. It's going by 2, so 1, 1 would be here, and then 2, 4 would be like that. And negative 2, 4 would be like that. Hopefully I did that right. So that's my parent function. I'm going to throw my values here. So 0 squared is 0, times negative 3 is 0, but plus 3 is 3. So it looks like it's shifting our graph, still going up by 3. Negative 3, so I can, maybe I'll do it off to the side here for this one at least. So if I put this in, negative 3 times 1 squared plus 3 is going to be negative 3 plus 3. This one's going to be 0. So again, my line of symmetry, that's 0. Then I do negative 3 times 2 squared plus 3. That's 4 times negative 3 is negative 12. Plus 3 is negative 9. So now, same thing here. I'm going to plot my points, draw a smooth curve. So I go 0, and then I go to positive 3. So that's going to bring me up here, 2, 3, right? And then from there, I'm going to go 1, 0. Spoiler alert, that's the solution to your function here. I kind of want to show you something, but I don't want to go into it. So wherever it crosses the x-axis, like we've said in the past, is one of the solutions. So then negative 1, 0 here. I'm so tempted to show you. I might show you. And then we have 2, negative 9, which is right about here. And then we just go over to here, and then draw our smooth curve. I Can't resist. Let me see if this works. So if we actually, went back and solved this, let me see if this would work. Negative 3x squared plus 3 equals 0. And we factored out, just like we did before, factor out a negative 3, right? And you're left with x squared minus 1 equals 0. And like we've been doing, special case here, this is negative 3x minus 1, x plus 1. And you're left with x equals 1, x equals negative 1. Mind blown. Seriously, that's where it crosses 1 and negative 1. Good stuff. Sorry, I couldn't help myself. So now let's do some comparison here. So both graphs have the same axis of line of symmetry, which is the y equals. So line of symmetry is still the y-axis. However, the graph of this negative 3x squared plus 3 is I'm trying to think of the words they want here. I'm just going to go with my own words because I think it's easier to explain. So what are the comparisons you can make here? Different vertex, shifted up 3. And why did that happen? Because our C value was plus 3. And then it was, and it's now facing down. What did that? The negative. And it's skinnier. And what did that? What's bigger than 1? The number 3. Again, sometimes I have a hard time filling these blanks because I don't know exactly the words they're wanting me to use there. All right, one more checkpoint, and then we'll be just about done and wrap it all up, and then we'll give you some classwork to do, and that, I believe, will be more, especially the length of these videos, that'll be more than enough for you to do until our next hangout on Wednesday. So look at this one, 1/4 x squared minus 6. So a tip here, all right, this is important. You're going to deal with the fraction 1/4. You're going to want to choose x values that when you square it are divisible by 4, okay? So again, let's just throw in y equals x squared quickly. I'll put it in here, 0, 0, 1, 1, 2, 2, 3, 4. Negative 2, 1, 2, 3, 4 goes off the graph, but this doesn't. Smooth curve, y equals x squared. All right, all right. Okay, so here, okay, going back to my tip, is I would not choose, like, for example, I would definitely not choose like 3. 3 squared is 9, and 9 times 1/4 is 9/4, which is all like kind of gross. So when you do your table of values, you choose x and y, and you definitely choose 0. And then instead of choosing 1 and like 3 or any of those odd numbers, I'm going to choose even numbers. I'm going to have you choose like 2 and 4, and that will give you negative 2 and negative 4. All right, so I'm going to pause. You should pause the video, try the checkpoint, and let's make some comparisons. All right, so if you did it, hopefully you got something that looks like this. I lost my other forever on this one here. So you can see here, let me just throw this other one, the x squared back in there. Roughly like that. That is not smooth. All right, so you can see, and I did do it a couple of years ago, like when I chose 1, there's that nasty fraction. I'm like, no more of that. But when you choose like 4, 4 squared is 16, and half of 16 is 8, and 8 minus 6 is negative 2. And same thing, 2 squared is 4, and 4 times 1/4 is 1, minus 6 is negative 5. And then if you know this is your line of symmetry and you get this, you know that. And if you get this, you get that. So Comparisons, I would say, let's look at the basics. Line of symmetry. Symmetry is the same. I would also say the vertex shifts down 6, right? What else would I say here? It shifts down 6, and then so we look at the symmetry, and then it's not skinnier, but because it's a fraction, it became wider. All right, so the last graphic here I really like here. So basically, I think this does a really nice job. So here, okay, so so when you compare it, right? If A is greater than 0 but less than 1, so basically, let's see what I'm gonna just double check this part. I think what this graphic is basically saying is if your A is positive, right, your parabolas are always going to be facing up, okay? But you can notice the wider ones, these are probably fractions, right? So that's what this says here. If A is greater than 1, it's going to get skinnier. And if A is a fraction, it's going to get wider. Okay? Uh, yeah. And then if you look here, same thing. But if your A is negative, your parabola is going to be facing down, right? And then you can see same thing as A is a negative fraction, it's going to get wider. If A is a fraction that is bigger than -1, like less than -1, like -3 is going to get skinnier. And then down here, you can see the C value basically just shifts it up and down your vertex. So here's a positive C, here's a negative C, and that's some of the basics. So again, um, between these two video references and going through these checkpoints, this could almost take both days worth of half-hour sessions that you should be doing at home. So yeah, I will assign a couple practice problems, but we won't go crazy. That way, we can have our check in Google Hangout on Wednesday.